interested in understanding the concept of amplitude modulation, it is the basic type of modulation in which the amplitude variation is observed. Here, the amplitude of the carrier signal is varied in accordance with the instantaneous value or the amplitude of the modulating signal. So, we have discussed this in earlier also. For any modulation, we require two signals. One is the modulating signal, that is the message signal. Another is the carrier signal. Let us consider this is our message signal, which is having amplitude EM, as I am marking here. This is the amplitude of the message signal, or it is also called as the modulating signal, having the amplitude of EM. In the same manner, in order to transmit this signal to a longer distance, we use another high frequency signal, and that high frequency signal we are calling as a carrier signal. So I will draw the carrier signal here. So this is the signal which is having higher frequency, and it will be carrying our signal to a longer distance. That's why it is called as carrier signal. We are marking the amplitude of carrier signal to be EC. So this is our carrier signal, right? Now mixing these two signals in such a manner that instantaneous value or the amplitude of this carrier signal varies in accordance with the amplitude of this modulating signal will result in a new signal that we called as a amplitude modulated signal. I will tell you the trick to draw this signal. First of all, let us draw two envelopes which are matching with this. Like this, I am drawing the upper envelope. This is how, because we are interested in representing the signal in double sideband full waveform. This thing I will explain in the coming time. So let us continue it like this. Yes. Now after making this envelope, this actually shows you the boundaries of the variation of this signal. Now what we have to do is we have to fill this with the carrier signal. So I can show like this. In this way, we can see here the amplitude of carrier signal is increasing as the amplitude of modulating signal has increased here. So amplitude of carrier has also increased, right? It is the maximum amplitude of this signal. After this, from here to here, the signal is decreasing. That's why again we can show that the amplitude of carrier signal is also going on decreasing here, right? This will continue actually up to this particular point, and that's why I have shown here like this. So simply if we fill this envelope by the high frequency variation of the signal, we get a beautiful waveform, and that is called as amplitude modulated signal. So this is the signal which we are called as a AM signal. So here I can write AM signal, that is nothing but amplitude modulated signal. So this is message signal, this is carrier signal, and this is the amplitude modulated signal. Let's have the remaining marking. So this is indicating the minimum amplitude of the signal. So this is the minimum amplitude of the amplitude modulated signal, while this is actually the maximum amplitude of the signal.